In this video, we will talk about the experimental observation analysis. On the first video, we have talked about constructing the design and performing the experiments. In this video, we will talk about analyzing the experimental observations. In this video, we will talk about analyzing the fit summary and analysis of variance table or ANOVA table. After that, we will analyze the diagnostics, and finally we will discuss the model graphs. This is our example. Our example was a central composite design with the three factors and one response, and our goal is to maximize the taste or maximization. This is our table. This is our responses that we collect. Let's go and see design expert. So after constructing your design and collecting all the data and writing it on the software, after that you have to go to analysis. The first step in analysis is transform. If you have a ratio greater than 10, usually indicates a transformation is required. Here in our case, we have a ratio of 2.116, which is not greater than 10, so we don't have to use any transformation here. On the second tab, we have fit summary. On the fit summary, there is 4 important values here. First, before that values, we have to, as we can see here, the software has suggested to us a quadratic model is the best suitable model in this case, with a p-value of 0.0001. These 4 factors are, or 4 values are very important. We will see them and explain them in the ANOVA table. To explain the ANOVA table, we have to we will see it here in the PowerPoint pattern. As we can see, ANOVA for quadratic model. This ANOVA is for the response 1 taste. The first 2 things that we have to check in the ANOVA table is the model and the lack of fit. The model must be significant with a p-value less than 0.05. In the other hand, the lack of fit mustn't be significant. It must be not significant. A not significant lack of fit is good. Not significant lack of fit, it means that the effect of the lack of fit on your model is not significant, is not important, which is good. You must check these 2 values. This one significant, this one not significant. All the other variables inside mustn't be, they don't have to be significant or not significant. We let them as they are. In this case, we have A, B, C, A, B, A, C, B, C, A squared, B squared, and C squared. Here from this table, as we can see that the p-values of A, C, A, B, A, C is not significant. This one and this one and this one and this one are not significant with p-value higher than 0.05. This means that they are not affecting the taste significantly. They only have a small effect on the taste. That doesn't mean that your results are wrong or something like that. This means that these factors are not affecting your. In the other hand, we have in this table another variables that they are significant with a p-value less than 0.05. A p-value of B, BC, A square and B square and C square is significant, means that they are affecting the taste response significantly. Changing them will have a big effect on the taste. Okay, these values are significant, which means that changing them or varying their level will affect the taste or the response significantly. Okay, now let's see these values. We have here fit statistics. The first value here is r square. R square must be close to 1. The closer to the units is the better. In our case we have 0.9, which is a very good value. We have the value of adjusted r square and predicted r square. The difference between them are less than 0.2. Here on the second area here, we have the final equation in terms of coded factors. From here we can take our equation as in terms of coded factors, which means of terms between 1 and -1, or we can take our equation in terms of actual factors with the names of variables and their actual values. Okay, as we can see them in this PowerPoint. Here we have the actual equation. This is the table. We can take all these values and write the equation like this. The taste equals, as we can see. Okay. After that, we can see the diagnostics. The diagnostics will give us an idea about our design. Is it fitting? Is it not? From here we can see that all our experiments are close to the line, which is a good thing. They must be close to the line. They mustn't be away from the line. Okay. Here we can see the report. The report. This report. We need this report to use it in our articles or our results, which contain the actual values and the predicted values. As we can see here, that the actual values and the predicted values are in good agreement. They are very close to each other, which is good, which means that our model is predicting the values in good way. Okay. If our system or our model needs a transformation, we will find it here. We will find it in this place. Software will recommend a transformation in this area here. Now let's go to the model graph. We can see it as contour plots or 3D surfaces. I usually like the contour plots. It shows the effects in a great way and that you explain it in a good way. For example, in this case, as we can see here, increasing the time from 10 to 30 have increased the taste significantly. As we can see here, the taste has been increased from 5.5 to 7 here to 7.3, which is a huge effect. In the other hand, changing the tea, the amount of dry tea leaves on our taste wasn't that significant. As we can see here, changing the amount of tea from 30 grams to 80 grams haven't affected the taste of tea significantly, from 5.5 to 6, which is only small effect on the response. Let's see now the interaction between A and C. The interaction between sugar and tea and their effect on the taste wasn't significant. increasing the T from 30 to around 55 have increased the taste of tea. A further increase in the tea have decreased the taste of tea. In the other hand, increase in the sugar from 4 to 6 have increased the taste of tea. A further increase in sugar have decreased the taste of tea. Let's see now the interaction between B and C. Let's see here. An increase in both of the time and sugar have increased the taste of tea. Let's see here. Increasing the time from 10 minutes to 30 minutes have increased the taste of tea significantly. Increasing the sugar from 4 to around 7 have increased the taste of tea significantly. A further increase have decreased the taste of tea slightly here. Okay, this is how we interrupt the contour plots. We can also see them as 3D surfaces. Here, it's also gives the same results and the same data. Here the interaction between A and B, and here the interaction between A and C, and here the interaction between B and C. On the next video, we'll talk about the optimization or the numerical optimization from here. So see you on the next video.